Hello guys, as promised, I am back with a video for how to find MAD. So what is MAD and what does that even stand for? Okay, so MAD is the mean absolute deviation of a data set. We know what mean is. We went over that a few videos back when we went over mean, median, mode. That's when you have, or when you find the average of a data set. So you're adding up all of your numbers and you're dividing up by how many numbers there are. A way we think about this is kind of the fair share. So say you had 2 pencils and I have 8 pencils. How many would we have if we split them evenly, if we each got our fair share? So in order to do that, you'd combine your 2 pencils with my 8 pencils to get 10 pencils, and then we would split them up by how many people there are. 2. So we would have 5 pencils each. I'd still have 10 pencils total, right? But now it's a fair share. So mean is that same concept, right? It's your fair share. Absolute, that is based on the absolute value, which is another thing that we went over a few videos back. Absolute value is how far away a number is from 0 on a number line. So basically, if I'm starting at 0 and I want to get to 15, how many steps would I have to take in order to get 15? 15, right? If I wanted to get to negative 15, how many steps would I take? Still 15 steps, just a different direction. So when we're talking about absolute value can never be negative because distance can't be negative. So mean, we know absolute value, we know deviation is the only new term here. So our deviation is essentially like how different are the numbers in this data set. The larger the deviation is, or the larger the MAD is, it means there's more variety, there's more differences in the numbers. This is going to make more sense as I do an example of it. But then the smaller the MAD is, that means that the numbers in our data set are all a lot closer together. Okay, to have this make a little bit more sense, I want to go over an example here. So in a few videos back, we went over finding the mean of the kids in my classroom. So if I'm teaching a 6th grade classroom, all of the kids in my class are going to be 11 or 12. In that situation, when we found mean, the mean was 11 and a half. Every kid's age is really, really, really close to that mean, right? Some kids are 11, some kids are 12. So the furthest away you're going to be is like half a year from that mean. Versus if I ask you something that we expect people to have more variety or bigger differences in their answers, my MAD will be larger. So if I'm talking about something like how many siblings do you have, that's going to have a larger MAD than how old you are if I'm only asking 11 and 12-year-olds. If I'm asking how many siblings we have, some kids might have no siblings, some kids might have 10 siblings, so there's going to be way different answers. The larger the bigger the difference is, or the more variety that there is in the answers, the larger the MAD is. Now, we have to figure out how to even find MAD. I think MAD's one of those things that makes more sense if we just do an example so that you can actually see what I'm talking about. Okay, so we're going to start off with this data set. If you have a pen or a paper or anything that you can write with, I suggest you getting it out now so that you can take notes and write down essentially the steps that we're going to be taking so that you can refer back to them later. So if you need to pause right now. All right, welcome back. I hope you have something to write down with. Okay, so when we are finding MAD, the first step is going to be to find the mean of the data set. This is what we're going to use throughout the problem. We're going to have to refer back to that. So make sure that you're finding the mean and make sure that you're finding it correctly, okay? So step one, that does not look very good. Find mean. All right, so in order to find mean, remember I have to add up all the numbers and divide by how many numbers there are. I want you to find the mean of this, so I want you to pause and come back when you have the mean. All right, welcome back. I hope you found the mean. So in order to do this, I'm going to add them up. So let's do 3 plus 6 is 9, plus 6 is 15, plus 7 is 22, 30, 41, 56, 82, is that, no, 50, did I just say 56? 72? 72? I think that I'm right here. I don't, hopefully, we'll see if the answer comes out right. 72 divided by 1, 2, 3, 4, 5, 6, 7, 8. 72 divided by 8, which would be 9, so my mean here would be 9. All right, now we have to do step 2. Step 2 is going to be find the difference between these numbers and the mean. So find the difference between your numbers and the mean. When I say difference, the operation that we're talking about is subtraction, but we're talking about the absolute deviation here. What that means is that, to be honest with you, okay, so my mean is 9. If my number's bigger than 9, I would just subtract, so like 15 minus 9. If my number's smaller, then it would be 9 minus 3. We're just finding the difference, the absolute difference. So we don't have to worry about negatives here because we're not talking about negatives. We're talking about the absolute value. Okay, so what I'm gonna do is I'm going to essentially subtract my bigger number from my smaller number with all of the numbers in my data set going with my mean. That sounds more confusing than it is. So what's the difference between 9 and 3? The difference, which we're talking about subtraction, is 6. I'm just going to write that in a different color up top. Can you even read that? Probably not very well. Let's see if this works better. What's the difference between 9 and 6? 3. We just solved that. The difference between 9 and 7 is 2. The difference between 9 and 8 is 1. The difference between 9 and 11 is 2. The difference between 9 and 15 is 6, and the difference between 9 and 16 is 7. So now I have all of my deviations. I see how far each number is from my mean. So I'm going to use a context here just to kind of see if it makes a little bit more sense. Let's say this is the average number of crayons in people's pencil boxes, okay? So on average, kids have 9 crayons in their pencil boxes. This kid only has 3. That means that he is 6 crayons away from being the average, right? This kid has 16. That means he is 7 crayons away from being the average. We're just trying to see, is everybody's answer kind of the same, or does everybody have completely different answers? That's exactly what mean, or what MAD is trying to figure out, is how different are the answers in this data set? Is there like a huge range in this data set, or are they all pretty close together? So we still have to do step 3. Step 3 now is finding the mean of the differences. So all that means is we're now just finding the mean of these numbers that I wrote in green. So in order to find mean, we know how to find mean because we've already gone through this. We just add them all up, divide by how many numbers there are. I want you to pause and I want you to add 6 plus 3 plus 3 plus 2 plus 1 plus 2 plus 6 plus 7, and I want you to divide by how many numbers there are. Okay, so if you added up all of these numbers together, you should have got 30 as your total, but we still need to divide by how many numbers there are. So 6 plus 3 plus 3 plus 2 plus 1 plus 2 plus 6 plus 7 is 30, but we still have to do 30 divided by, there's 1, 2, 3, 4, 5, 6, 7, 8 numbers. 30 divided by 8, you can either solve this or you can use a calculator. The reason that I'm telling you that you can use a calculator on this problem is because my concern right now is not that you know how to divide decimals. I mean, that absolutely is the standard. You absolutely should know how to do that. But right now, what I'm concerned about in this lesson is you knowing how to find MAD. So focus less on dividing decimals correctly, focus more on remembering the steps and remembering what MAD even means. So if you did 30 divided by 8 and you wrote it out, or if you used a calculator, you should get 3 75 hundredths, or 3.75. So what that means is our MAD is 3.75. All right, I'm going to set this problem up in just a slightly different way. I'm doing all the same steps. I just think that this way is a little bit cleaner. So I'm going to write mean up top, and then I'm going to write my data set. You'll see why as I'm going through. So my first step in solving MAD is is finding the mean of my data set. So in order to find mean, remember I add up all my numbers and divide by how many numbers there are. I want you to pause and I want you to find the mean of this data set. Come back when you have it. You should have got 13. So if you added up all these numbers, I want to say it's 65 divided by 5 is 13. So our mean is 13. So my second step now is finding the difference. How different is this number from all of these numbers? What's the absolute deviation of these numbers? So basically, 13 is how many steps away from 12? 1, right? 13 is how far away or how different from 13? Nothing. They're right next to each other, right? They're the same number. They're together. 12, we already solved, is 1. The difference between 13 and 14, 1. The difference between 13 and 14, 1. Now, what I have to do is just find the mean of these numbers. So at 1, 2, 3, 4. So I have 4 divided by 1, 2, 3, 4, 5 numbers, which again, you could either do on a calculator or you could write it out as like 4 divided by 5. And we can even go through this. 4.0. So your answer should be 8/10. So what that means is that that's not right, sorry. The MAD of this data set is 8/10. Okay, so the reason I use this data set, is basically just to show you the difference between this one and the last one. So the last one, our MAD was 3 7/500ths, or 3.75, right? This one, the MAD is only 0.8. What that means is that there was a greater variety of numbers in that first problem than there are in this problem. This problem, all the numbers are really close to each other, right? The smallest number is 12, and the biggest number is 14. Those are all pretty close together, 12, 13, and 14. Like there's not that much variation between those numbers. Versus in my last problem, the numbers were way more spread out. The more spread out your numbers are, or the greater the range of your data set is, the bigger your MAD is going to be. So my MAD here, 8/10, is a lot smaller than 3 7/500ths. So we know that this data set is basically, there's less differences in it. It has a smaller MAD. There's less of a deviation, is I guess what I can say. All right, I want to do one more sample problem with this data set. So first step, finding the mean of these numbers, aka adding them all up and dividing by how many numbers there are. I want you to pause and I want you to find the mean of this data set and come back when you have it. Welcome back. All right, if you added up all of these numbers, well, I still have to add them all up. Like I told you, if you want to use a calculator right now, absolutely go for it, because I'm not testing your knowledge on adding, I'm testing your knowledge on finding MAD. So I'm going to do 14 plus 11 plus 12 plus 13 plus 6 plus 13 plus 15. My total was 84 divided by 1, 2, 3, 4, 5, 6, 7 numbers. Your answer, or your mean, should be, that does not look very good, but your mean should be 12. So I don't need this. This might be a little distracting. So now I'm going to find how different are these numbers from my mean. How far away are they, essentially? So if I'm at 12, how far do I have to go to get to 14? Right, that's 2. How far away is 11 and 12? 1. 12 and 12 right next to each other. Difference between 12 and 13, 1. 12 and 6, 6. 12 and 13, 1. 12 and 15 is 3. Now I have to find the mean of these differences. So I'm just adding these numbers up and dividing by how many numbers I have. So I want you to pause and I want you to do that. Welcome back. So you should have done 3, 4, 10, 14 divided by 1, 2, we just did this, 7 numbers. 14 divided by 7 is 2, which means that our MAD of this data set is 2. All right. This is actually a concept that I'm having some problems finding sample worksheets on. I'll see what I can find, and if I can find something, I'll link it down below. But if not, you can honestly just come up with numbers and find your own MAD. It's going to be difficult to check your answers, but there might be a MAD calculator. I'll see what I can find. I'll link it down below. As always, if you have any questions, feel free to message, comment, whatever. We're going to continue going into statistics. We have a few more concepts to cover before the end of this module. But if you need any help at all, message me. Bye, guys.